Hello, I'm Roger Bisbee from the Skill Builder channel, and in this video I want to take you through the installation of a right pump from Salamander. Now, I've built this little mock-up because it's a lot easier for filming, but this did come from a bathroom. It was just a little bit too pokey for us to get the camera and the lights in, but everything here is typical of many flats particularly, and some houses. The pressure that you get, or the flow rate that you get from your shower, is determined in this case with the gravity system by how high your cold water tank is above the shower head. Because what happens is that water is trying to find its own level, so it's pushing down and it's pushing up into the shower. But if there isn't a great deal of difference between those two levels, you will get a very miserable little flow. Fortunately, this problem can be solved with the fitting of a Salamander right pump, but there are different pumps for different installations. So let me take you through just a little bit of theory so that you can choose the right pump. Now, the pressure is determined by the bottom of the cold water tank and the height that is above the shower head. And in this case, you can see that is absolutely, well, nothing really. But if your tank was in the loft, you would have a positive head, you would have a reasonable amount of flow to get the pump going. So in that case, you would choose a positive head pump. Now, in this case, because that is so close, there won't be enough flow going through it to get the pump going, so we're going to put a negative head pump in here, which is the same pump that you would use in something like a loft conversion, for example, if you had a shower which was actually above the level of your cold water tank. So that's what we call a negative head. You need a negative head pump, and that actually senses that the water is starting to flow through a little pressure vessel that's on the pump itself. So in this case, we're going to use a negative head pump. Now, some people do have a situation they use a positive head pump, and what they have to do is this. They switch the shower on, they lower the shower head down until it's a couple of feet below the level of the cold water tank, and that starts the pump going. But obviously that's not ideal, so it's much better to use a negative head pump. Now, as a jobbing plumber, I go out to a lot of houses where they've got problems with showers, problems with pumps and all kinds of things. And very often it turns out to be an installation fault. Somebody has not followed the rules, they haven't followed the instructions, and very often they've tried to take a shortcut. What I'm going to show you here is the way to fit a shower pump to avoid all those problems. If you want to take a deep dive into the science of shower pumps and flows and pressures, we are going to do a special video which covers the theory. But here I just want to show you the basics and the practical side of it. But I'm not going to show you how to join pipes because that is another video. Again, you can look on our channel and you can find plenty of videos on how to join pipes. We've got a cold water tank here, and the cold water comes down through here. This is the valve for turning off your hot water. It's actually the cold water that you turn off, because what that does is it pushes water out the top of the cylinder. You never ever put a valve on here because that could cause the cylinder to blow up. So the valve always goes on the inlet to the hot water cylinder. And then we've got a free passage up this vent pipe, and this vent pipe hooks over the top of the tank. So if there was excess heat pressure, if it started to boil, for instance, it would just send the water up into the cold tank and relieve the pressure. So that's a bit of safety. The way that we drain this cylinder down in order to fit the shower pump is we use the drain cock at the bottom and we put a hose pipe on it, and then we can just run the water out. We don't actually need to run all the water out of this cylinder. If we take it down to about there, we'll be absolutely fine. Sometimes you find that these drain cocks are a little bit blocked up and they don't drain well. And sometimes I've even had to put a hose pipe in the top of the cylinder and siphon the water out of there. But it's just one of those things that plumbers do. So we need to get hot water to the shower pump in order to feed it to the shower. You do see people who just simply tee off, add a branch on this pipe here and feed that into the shower pump. Now what can happen there is that the shower pump is very powerful, and what that can do is it can actually suck air down through this vent pipe. Then you get a spluttering shower, or it doesn't even work. In order to overcome that problem and also to validate the guarantee, you've got two ways of fitting this pump. If you've got sufficient head above the cylinder, you can fit what we call an S flange. Now it's a beautiful bit of kit from Salamander, and the idea is that this is going to sit in the top of the cylinder and it's going to draw its hot water up through this pipe here, and it's going to come out of that branch there. The other one is basically going to carry on venting the cylinder and also supplying all the other hot water in the house. So it's important that if you are going to supply taps that you choose the right pump, and Salamander will give you plenty of advice. Their literature will help you, their website will help you, but if you get stuck, just give them a call. So what determines whether you can use this S flange or whether you have to use what we call an Essex flange, which is a bit more involved, is the height of the cold water tank above the top of the cylinder. And we can see here that we've actually got 4 feet. So we could fit this S flange. But for me, it's kind of on the cusp, but because I don't want any trouble, I'm going to go for the other option, which is to fit an Essex flange. But I'm going to show you how to fit both. Now if we look here, we can see that the tapping for the pump is this one here. That goes straight into that tube, so it's going to suck the water, and the other one is there, so don't get that wrong. Also, we've got a reducing bush here, so if we wanted to come out with 28mm pipework, as some do at the top, we can do that just by removing that reducing bush. But for us, we've got 22mm pipework, and I'm going to put some thread sealant on this and screw it into the top of there. So you can see here on the instructions that they give you the option of using the male or the female thread, so that's fine, it covers both of them. It also shows you here we've got the pump supply and we've also got the gravity supply going out to the rest of them. So I've got to use some thread sealant on here. I can do that with PTFE tape around there, but in order to get a lot of tape around there, I'm going to cut a little bit of this insulation away around the top. While being careful not to drop that inside the cylinder, because we don't want that floating to the top and clogging up the pump. The pump has got filters on it if the worst came to the worst, but the less we get on there, the better. Now I'm going to go around with the PTFE tape because that's the more usual way of doing it, but I would just mention, it's not an advert, but this is brilliant. It's a thread sealant. Just put this round the threads and it will set. Places where it's difficult to get PTFE tape in, this is a very good alternative. To be honest, if I was doing this as a proper job and I was leaving it, I'd probably use the Loctite. So you can see how awkward that is to actually get that tape around that thread. So there is one more alternative. You can actually use this thread sealant cord instead of the tape, which I really like. So again, I'd probably do that rather than the tape. You don't actually have to worry with this about getting it in the threads, but it does tend to just want to follow them anyway. But put plenty in. Okay. That's very tight actually, but the great thing about using thread sealant or even this 577 is that you can back off, which you can't do with PTFE tape. And what I mean by that is if we got round here and this branch was directly over the top of the immersion heater, we wouldn't want that. And what you can do is just simply turn it back a bit and it will still be okay. In this case, no need to do that. We'll just turn it round and think about where we're going to go with it. That's as far as I'm going to go for a moment, because I'm going to get the pump out and just offer the pump in and see where I want to put that in the base, because you must put that down as low as you possibly can. It's a really good idea if you can to get it down at the same level as the bottom of the cylinder, because that means that under all conditions that pump is full with water all the time. It's what we call flooded with water, and that means you're not going to be drawing air into it. If you put it up here, you can do that. If you were, say, putting it in a loft, you were going across, but you do risk problems with air. So in the top here, they give you the golden rules, if you like, the things you mustn't do. And one of them is you must not put it on mains water supply. Use it only with stored water. You also shouldn't let any solder flux come into contact with the pump. Now, that doesn't mean you can't use solder fittings. What it does mean is that if you've used solder fittings when there's flux in the pipework, you need to flush that through thoroughly before you connect up the pump. Now, one way to get around that is to either use push fit fittings, which if you don't do a lot of plumbing is a great idea, or you can use compression fittings, which I quite like. Now, another very important point is that you mustn't have your hot water more than 60 degrees Celsius. I have been to houses, for example, where they've got an Argo or they've got solid fuel and the water temperature is way above that 60 degrees. The other important point they mentioned here is that you must connect up to either an S flange, as we have here, or an Essex flange, and not just tap it into the pipework. So we've covered that. The one we haven't covered is it says you must ensure an adequate cold water supply for this pump. And they talk about 50 gallons being the minimum, which is a standard cold water storage tank. Now you can see in this case, we've got a smaller storage tank. So we would be in danger of running out, if you like, if somebody just stayed in the shower too long. And in that case, we'd be looking to add water storage to the system, not by taking this tank out, but simply by putting another tank next to it and connecting up to that tank with a pipe that basically goes from one tank to the other. As water finds its own level, so long as those tanks are on the same level, it will flood into the other tank. So just one final thing I'm going to say is that we've got a cold water supply for this cylinder. We don't have a cold water supply for the pump, which means I'm going to have to tap into this cylinder with another tank connector so that I can bring some cold water down to feed that shower pump. Put it in there. We're going to put some anti-vibration feet on there. I could put it here, this would be all right. It's right in front of a cylinder, which is not ideal, but it's quite easy to remove these. It's just push fit fittings. Or another alternative is I could just make up a bit of timber for the side and stick it in there. The only thing I don't like about sticking it in there is that here's a shower wall. We could get a bit of vibration passing through. So I'm really happy. Let's keep it simple and put it there. So 2 connectors on the end, plenty of room for those, and the outlets are going to come through the top, and they're going to go directly up to this shower valve here, which is 15mm, but I think I'm going to run them out in 22 and then reduce them when I get up there. I'm going to use a combination of solder and push fits. I always like to put push fits onto the actual shower valve itself, because if ever I need to do anything, it's a lot easier if you're changing shower valves. Very easy. Now you notice that I've put hot and cold on here. I know which way round it is. Hot on the left, cold on the right. But when you come around here, suddenly, oh, you're hot on the right. So I just do that because I've been out of so many showers which have been connected the wrong way round, and they don't work.
Have you got left and right on your shoes as well?
So I'll go 9.5 here. That looks like 90 to me. A lovely invention, really, aren't they? Now, having fitted this S-flange, you can see that the pipework is dipping down slightly, which is a very bad thing because this is taking the air out of a cylinder. The way this is designed is that it turbulates the air all around the edge of the cylinder. It comes up and it removes it. So we need to make sure this pipe isn't trapping air in a high spot. If that pipe's running downwards, we've got a high spot here where we get an airlock. So we have to just make sure that pipe is up. And it can be level. It'll work level but I always just try and give it a little bit more than that, somewhere around there. So if I cut that pipe there, I'm going to move that T up into place, and then I'll just have to extend that bit of pipe below. Now, the last bit that I've got to do is to get this cold supply in, which means tapping into this tank. The way I do that is with a tank connector. Now, this is a conventional tank connector. So what you do is you drill a hole in the tank, you put that through from the inside, and then you put the nut on the outside, tighten it up, and if you're very lucky, you won't get any weeping along the threads, but very often you have to wrap that with a bit of PTFE tape when it goes in to do it. Now, the trouble with doing it is that you can find that this just rotates a bit, so those little lugs are so that you can hold the inside of it while you tighten the outside, which is fine if the tank happens to be on the ground and you're putting the tank connectors in, but if you're doing it up here, it's a problem. So once again, the wonders of science solve the problem. This one is a JG Speedfit tank connector, and I just use these all the time now. I don't use anything else because that is just such a beautiful hand tightenable. It's got the rubber washer there already on it. So you put that through from the inside. You've still got to drill the hole in the same way. Put that through from the inside. Put the outside on. No need for any PTFE tape. No need for any sealant or anything like that. And you can tighten that up, and you find that actually it'll tighten without spinning that round on the inside. But if it did happen that you had to just turn it a little bit on the inside, you could do it. And then it's just a simple push fit for the pipe into there in the conventional way. So a much better product, especially for this kind of job. So the idea of this is we actually put the outlet the opposite end to the inlet. So the ball valve is feeding the tank from that end, so we would put our connector in somewhere down here. Now, this is the cold, and what we normally do is we put the cold in lower than the hot, so that if it did run the tank dry, the last thing you would lose is the cold water. That way, you're not going to get scalded suddenly by having just hot. So I'm going to put that down there as low as possible, but obviously I want to save coming up against the curve of the tank. The other thing that's very important is that inside this tank are some baffles, which are bits welded on. So I just need to get up there. And if you can't do it, you can use your phone to take a picture, or you can just put a mirror up there and have a look with a torch and a mirror to check what's going on. But in this case, I've got enough room to get my head in there. Just have to clean that bit of swarf off the tank there, just to make sure that it's clean. Sometimes just do that with a little Stanley blade or something, but anything to do it. It's all about getting a nice seal on the inside. We're not worried about the outside as such. Check the washers in place on the inside. That goes through. Just give that a little tighten up. No need to go crazy. You could put some grips on it, but quite honestly, I've never had a leak with these. So if you're doing that job, don't put any sealants on it, don't put any paste on it or anything like that. And the other thing I've seen people do is if they haven't got the right size hole saw, they get a bit of copper tube, heat that up and then plunge it through the tank. You see plumbers doing that, and that's a very bad idea, because what that does is it heats up that bit of tank locally there, and it loses its plasticity, and the tank can then split. So always a hole saw, never a hot pipe. Let's get a new pipe slice. And then one at the bottom. Okay, that's fine. Now I've just fitted a lever valve there, which is what I fit now, because these gate valves are an absolute nightmare. Sometimes they work, sometimes they don't. sometimes they're just jam solid. And the best thing to do if you're draining a tank, you might as well get rid of those if they're not working and fit some nice lever valves. Interesting little thing here, let's remove this sticker, and this sticker says that you've got to put the pressure vessel on. Now this is the thing that turns it into a negative head pump. When you turn on the shower or the tap or whatever it is you're using, by the way, you only do this hand tight, the pressure that's in that vessel pushes the water out, if you like, and that starts the pump going. So as soon as you open the shower valve, pressure drops in there, the water goes out, and so even if this pump is above the level of the cold water tank, because it's built this little bit of pressure up, it will hold it. The other thing that can happen is you can lose pressure from the pressure vessel itself. When I've been out to these things, people say the shower's not working. Very, very simple. Just get my bike pump, put a little bit of air back in there. It tells you how much to put in there, 30 psi. You put 30 psi back in there, and then that starts it. But when you put the 30 psi in there, turn on the shower valve, because otherwise you're trying to pressure against a dead head. So it's best to do it with the shower valve open. So we've done that, and because I've managed to avoid any solder fittings in all this little bit here, I haven't got to worry about flushing the pipework through. I might do if I had any kind of fear of debris in there or anything like that, but it's the flux that was the concern, and we haven't got any flux in there. Now here's the washers in the little pack, and you'll see that they've got washers with filters and washers without, and it doesn't take a genius to work out that the filters go on the inlet to the pump and the other ones without the filters go on the outlet. So get that the right way round and then screw that up. Again, no sealants required, no PTFE tape. That washer's got to do the job, and all we've got to do is go hand tight with them. There's no need to put a wrench on them. They're plastic fittings and they do not need any extra force on them. Now I almost forgot, we've got some anti-vibration feet to go on the bottom here. Right, the important thing is we don't want the vibration going through. That's it. That's the flow up there. It's not even on. Right, here's the thing, okay? Let me just show you what happens with this going. Right, if I take this off and I lower it down, you can see that having that extra bit of head just allows it to flow. And that's what you call a miserable little shower, isn't it? I mean, my goodness, look at that. Switch the pump back on again. Now when I turn this off, you'll hear the motor, and it'll just run until it's recharged that pressure vessel, and then it'll switch off. Pumping that back up to 30 psi. Therefore, when it turns back on again, we've got that initial surge of water. Now, if ever there was a justification for putting a pump in, this is it. So that was the fitting of the right pump. This is the top of the range one, and this is good for positive or negative head. You can use it for all manner of different applications. If you're running 2 showers at the same time, then this is definitely the one that you want. And if you want to find out more about Salamander's range of right pumps, or any of our other pumps come to that, then follow the link to their website.